Hello students, welcome to the next module of the chapter surface tension. And in this module we are going to learn about shape of the liquid. Now class, consider a system made up of three things. That is, I have a solid substance and on that solid substance I have a liquid drop. And the solid and the liquid, they both are in contact with air. So I can say that this system consists of three different media, that is solid, liquid and air. Now I say that there is surface tension along a surface between liquid and air, solid and air, and liquid and solid. Remember class, whenever there is change in medium, the force of surface tension always exists there. Now, since we have three mediums here, I have three kinds of surface tension force, and they are the force between liquid and air, solid and air, and liquid and solid. Now class, I say that T1 is the force due to surface tension at the liquid and solid interface. Remember class, I repeat the statement again. Whenever there is change in media, there is always force of surface tension at the separation, or I can say that at the boundary of those two media. So now I say that T1 is the force due to surface tension at the liquid and solid interface. So as you can see in the diagram, T1 is the force as shown. Similarly, I can say that T2 is the force due to surface tension at the solid and air interface, which is something like this. And finally, I have T3 as the force due to surface tension at the interface between air and liquid, which is something as shown with the help of green arrow. Now class, if I consider theta to be the angle of contact, I say that the green colored arrow, that is T3, which is nothing but the interface between air and solid, that is nothing but the interface between air and liquid. I say that if I were to resolve, I could resolve along x-axis as T3 cos theta and along y-axis as T3 sin theta. Now class, if I keep the diagram with me as it is, I can see that for the equilibrium of the drop, I can say that all the forces which are towards right hand side should be equal to all the forces which are towards left hand side. Now class, if you look at the diagram carefully, I can say that all the forces which are on the right hand side are nothing but T3 cos theta and T1, and the forces which are there on the left hand side are T2. So for the equilibrium of the drop, I have to satisfy this condition, that is T2 is equal to T1 plus T3 cos theta. From this equation, I can say that is cos theta is equal to T2 minus 1 upon T3. Now class, I say that if T2 is more than T1, now class, if you look at the equation which is there, I say that since T2 is more than T1, that is T2 minus T1 will be a positive value, and if T2 minus T1 is less than T3, I can say that cos theta is positive because this value will be in a fraction. So I say that if cos theta is positive, therefore angle of contact has to be acute. That is, the liquid drop will take a more in flat shape. Now I say that if T2 is less than T1, now class, if T2 is less than T1, that means the numerator, okay, that means the numerator will be negative. And if I say that T1 minus T2 is less than T3, I say that numerator will be negative, and since T2 minus T1 is less than T3, the value is less than 1. So I say that cos theta is negative, and since it is negative value, angle of contact, that is theta, has to be more than 90. So that is, I say that, and angle of contact, that is theta, is obtuse. Now, if we talk about the third case, I say that if T2 minus T1 is equal to T3, that is, the numerator and the denominator have same value, that means the value will cancel, and answer will be cos theta will be equal to 1. And now class, if cos theta is equal to 1, I can say that this is not 0. Now, that is, cos theta is equal to 1, then theta is nearly equal to 0. Okay class, because we know that cos 0 is equal to 1. And looking for the last case, I say that if T2 minus T1 is more than T3, now class, remember, if T2 minus T1, that is whatever value I have in the numerator, if it is more than the denominator, that means I can say that my cos theta will be more than 1, which is just not possible class. Cos theta value lies between minus 1 and 1. So value of cos theta more than 1, it is not possible. So I can say that in that case, liquid will spread over the solid surface. I hope you have understood the module class. See you in the next module. Thank you.